All right, good morning guys. Today we're going to be covering 10.5, volume of pyramids and cones. Our learning target is I can find the volume of pyramids and cones. So let's go ahead and get started. Compare a pyramid and a rectangular prism with the same base and the same height. What fraction of the volume of the box is taken up by the pyramid? So what I want to know is what is the percentage that the pyramid is taking up of the box? Well, if we would check this out, we would actually be able to see that we can pour 3 pyramids into one full box. So therefore it takes up 1/3 or 33% of the box. And that's going to be really key for our lesson today. And if you're not sure of this, if you want to actually see it in person, just YouTube how much volume will a pyramid fit into a rectangular prism. And it will actually show you the exact amount of pouring in that would occur. And it takes 3 times to pour it in. So it takes the volume of 3 pyramids to fill in 1 prism with the same base and height. So that means that we need to fill it up 3 times with that same pyramid to get to remotely the same volume. And in fact, it's exactly 1/3. So that 1/3 leads us to our formula for the volume of a pyramid. That formula is 1/3 base times height. Very similar to what we saw in our previous video with cylinders and prisms, where it's just volume is equal to big B times H. This time, we're just multiplying that by 1/3. So volume is equal to 1/3 times big B times H. Now, of course, big B is the area of our base, so that will change depending on what shape we're given. So if I have a triangle down here, then of course I'd use the area of a triangle. And if I had a pentagon down here, I'd use the area of a pentagon. So it just changes based upon the shape. Meanwhile, height will always be from the very center point of our pyramid straight down to the center. If it goes along the face, we call that the slant height. And if it goes along one of these edges here, the side of the pyramid, that's called a lateral edge. So neither of those would be the height. Again, the height needs to start from the center and go straight down and intersect at 90 degrees. Let's go ahead and see some pyramids examples in action. So we want to find the volume of this pyramid. And the first thing that we want to know is what type of pyramid is this? So looking at the base, we have a base of 6 and a base of 5 for our base, those 2 side lengths. So that means that we have a rectangular pyramid because our base is a rectangle. If I have a rectangular pyramid, then of course I'm going to use the area of a rectangle for my base. We're also given the height right away. As we can see, this is not a right pyramid. The point is not right above the center of our pyramid. It's kind of off to the side. However, they tell me that from the top point down to the base is 4 units. So that's our height. Plugging in the area of a rectangle for big B and the height of our prism for H, we're left with volume is equal to 1/3 times 6 times 5 times 4. 6 times 5 will give me the area of my base, which is 30. 30 divided by 3 is 10. And 10 times 4 is 40 units squared. Cubed. 40 units cubed. We're in 3 dimensions. 3-dimensional space will deal with cubed units. All right, let's try out another one. Here we have another pyramid, and we want to find the volume of this pyramid. Now, looking at our base, what type of pyramid is this? Well, since 2 consecutive sides are congruent, this is a square pyramid. And along with that, they give us the slant height here along the face of our triangle. So they tell me that the slant height is 13. Since this is a square, we should be able to find this distance down below here. Since it goes to the middle of our pyramid, that means that this distance should be 5 units in length. So if it's 5 units in length, I can use Pythagorean's theorem to solve for the height of my pyramid. So therefore, I'm going to have 5 squared plus h squared equals 13 squared. Again, 5 squared plus h squared equals 13 squared. Of course, this is a Pythagorean triple. This is a 5, 12, 13 triangle. So when I solve for h, we're going to see that h is equal to 12. course, we can see that when I square 5 and 13, 5 squared is 25, 13 squared is 169, 169 minus 25 is 144. Of course, we know that the square root of 144 is 12. So therefore, h equals 12. Now that we have h, I can plug in 12 for h. What can I plug in for b? Well, that'd be the area of the base. And since it's a square, it'd just be 10 times 10. So volume is equal to 1/3 times 10 times 10, or 100, times 12. 10 times 10, again, is 100. 100 times 12 is 1,200. 1,200 divided by 3 is 400 units cubed. All right, let's go ahead and try out another pyramid. This time, our base is going to change once again. So what type of pyramid is this? Well, this is a triangular pyramid because our base is a triangle. And with this triangular pyramid, we may notice something unique about the base. For our base, we have an isosceles triangle. We have two sides that are the same length. Now, of course, this is not a 45, 45, 90 triangle, because if it was, the 6 would be a 5 radical 2, because again, that'd be x, x, x rad 2. So since this is not 5 radical 2, I actually need to find the height, because I don't have a right angle in this triangle. So we're going to use our volume formula, 1/3 big B times h. And I'm going to go ahead and take this triangle here, and I'm going to draw it out in 2 dimensions to help solve for it. Now I can see that I have the height already for my for my pyramid, so I can plug in 4 for h, but I still need big B. So I'm going to go ahead and draw that triangle, and of course I see my 2 isosceles sides with 5 and 5. And then if I draw in my vertex, from this vertex, if I draw in an altitude, that will split the opposite side perfectly in half. And the reason it does that is because in an isosceles triangle, the altitude is also a perpendicular bisector. So it splits that base of 6 into 3 and 3. Now at this point, I have 2 right triangles. I can use either one to solve for a. I'm going to use Pythagorean's theorem to do that. So I have 3 squared plus a squared equals 5 squared. Now, of course, you may be able to look at this and tell me this is a 3 blank 5 triangle, or a 3, 4, 5 triangle, and you'd be able to know that a is equal to 4 right away. If that's the case, you don't need to do all this extra work here if you know your Pythagorean triples. Now that I have a is equal to 4, I need to go ahead and solve for big B. Well, big B is the area of the base. And if I have a triangle, we need to use the area of a triangle. Big B is equal to 1/2 base times height in terms of my triangle here. Not of my pyramid, but of just this triangle. Now looking at this, our height and our base must always be perpendicular. So we just found the height as 4, and of course we see that it intersects at a right angle with the side length of 6. So 6 must be the base of my triangle. So therefore I have base, big B, for the area of my base here, is equal to 1/2 times our base, 6, times our height, 4. 6 times 4 is 24. 24 cut in half is 12. So big B equals 12 units. We can finally plug into our volume. Volume is equal to 1/3 times 12 times 4. 12 times 4 is 48. 48 divided by 3 is 16 units cubed. All right, we got one more pyramid. Our final pyramid is a pentagonal pyramid. So looking here, we have a pentagon as our base, 5 congruent sides, and it's a regular pentagon. And they tell me that the base area is 40 feet squared. I can also see that the height of this pyramid is 10. So what can I use the base area for? Well, if we recall, big B is equal to the area of the base, or the base area. So they're already telling me that big B is equal to 70. If that's the case, I already have big B and I already have h, so I can just plug in and solve. This will give me volume is equal to 1/3 times 70 times 10. 70 times 10 is 700, so we're left with 1/3 of 700. If I take 700 and divide by 3, I'm left with 233.3 units cubed. All right, that's it for pyramids. Again, the concept is just find the area of your base, multiply it by your height, and then make sure that you divide by 3. And we're always dividing by 3 if our figure ends at a point. So next up, we have cones. Cones are extremely similar to pyramids because they end at that single point at the very top. So the only difference between the volume formula for a pyramid and the volume formula for a cone is that I'm using a circle formula for the area of my base. So since it's a circle for my base, the area of a circle is pi r squared. So it's still going to be big B times h, but big B is now pi r squared, because a cone will always have a circle as its base. Let's go ahead and use this equation to solve for a couple cones. We want to find the volume of a cone with a radius of 3 centimeters and a height of 5 centimeters. So they already gave me the radius and the height, and that's all I need for the volume formula. So volume is equal to 1/3 times pi r squared times height. Plugging in 3 for r and 5 for h, I'm going to have volume is equal to 1/3 times pi times 3 squared, or 9 pi, times 5. 9 times 5 is 45. So I have 45 pi divided by 3, which is 15 pi units cubed. In this case, centimeters, because that's the units that they gave us. So again, just treat it the same as a pyramid, but use the area of a circle in replace of big B. All right, next up, we want to find the volume of the cone. The first thing that we should be asking ourselves for this problem is, what's given to us? Well, looking here, we have 41, which is our slant height, which we don't use, and then we also have 40, our actual height of the cone itself. What are we missing? Well, we're missing the radius. But if I look here, I see that we have a right triangle, and I have 2 sides of that right triangle. So I can use Pythagorean's theorem to solve for our radius. That will be r squared plus 40 squared equals 41 squared. And this is a Pythagorean triple. 40 squared is 1600. 41 squared is 1681. If I subtract 1600 from both sides, I'm left with r squared equals 81. Square root of 81 will leave us with 9. So we have a radius of 9, a height of 40. Plugging into our volume formula, I'll have volume is equal to 1/3 times pi times 9 squared, or 81 pi, times 40. 81 pi divided by 3 is 27 pi. 27 pi times 40 is 1080 pi. So our answer is 1080 pi units cubed. All right. Our final problem of the day is to find the volume of a composite figure. Now again, since it's volume, this shouldn't be difficult. If it was surface area, then we'd need to be thinking what's being covered. But for volume, we need to do for this is find the volume of each shape. And then since they are not going into each other, since my cone is not facing upward like this, since it's facing downward, I just need to add those together, and that will give me the full volume. So let's go ahead and start with our cylinder. The volume of a cylinder is just going to be big B times h, and since the base is a circle, it's going to be volume is equal to pi r squared times h. Of course, since I have a diameter of 6, my radius will be 3. And looking at our cylinder, we have a height of 50, so h is 50. Plugging into our formula, we'll be left with 9 pi, that's 3 squared. So 9 pi times 50. 9 times 50 is 450. So our answer for the cylinder is 450 pi units cubed. Next, we need to move on to our cone. And for our cone, we know that we're going to use volume is equal to 1/3 pi r squared times h. Now, in this case, our radius hasn't changed. Our radius is still 3 because both the top base and the bottom base are the same circle. But our height has changed. The height is no longer 50 because that belongs just to the cylinder. So to find our new height, I can go ahead and draw it in. And since it goes from the center of our circle straight to the point, it will also match up with the radius. So this creates a nice right triangle for us. In fact, this is a 3, 4, 5 triangle. So we can solve for h by using Pythagorean's theorem or just using your Pythagorean triples. Of course, h will be equal to 4 because it's a 3, 4, 5 triangle. Now that I have the height of my cone and the radius of my cone, I can go ahead and plug in. Volume is equal to 1/3 times pi times 3 squared, or 9 pi again, times 4. 1/3 times 9 pi will give me 3 pi. 3 pi times 4 is 12 pi units cubed. We now have the volume of each shape. Now that we have both volumes, the last step is to combine them together to get the total volume. So our total volume will be 450 pi plus 12 pi. Combining those together, we'll get 462 pi units cubed. All right, guys, thank you so much for watching today. If you have any questions, please let me know, but have a great rest of your day.